Very good morning, guys. Welcome to my channel. And today I'm going to let you know about the inductive effect, how these effects can affect the whole compound, its acidity, and there are so many factors that it can affect. So first, I'll let you know what is inductive effect. In the inductive effect, there is a displacement of the sigma electrons. So basically, if I'll say that there is a shift, but it is partial shift. We always denote partial as delta. So there is a shifting of the electrons. Which electron? Sigma, not pi electron. Sigma electrons towards more electronegative atom of the sigma bond. If I'll take this example, where chlorine is attached to this carbon chain, this chlorine is electronegative than this carbon. So it attracted its electron, share electron towards itself and generating the partial charge, that is delta charge. So there is two delta plus. That means it also attracted the electron from the second carbon, but lesser. But more effect of this electronegative atom on this carbon. So if I'll say there is a shift of or displacement of the sigma electron towards electronegative atom of the sigma bond is called inductive effect. This is a permanent effect. It can happen that electronegative atom can be attached to the whole group, but it also can be happen that electropositive atom is also that donate the electrons. So that we will see in the next slides. First, you should understand that there is a partial shifting or displacement of only the sigma electrons when any electronegative atom is attached to the chain. So, yes, it is distance dependent. That means if there is another carbon is attached here, suppose, so then there is 3 delta charge. So effect of this electron atom is lesser on this carbon, more on the first carbon. As the distance increases, effect is going to be decreases. And it is operated through only sigma bond. There is no pi bond is required. So it is also negligible after the third carbon atom. So it's not longer, long distance. It never operated on a long distance carbon. So here CH bond is the reference of the inductive effect. You can say it simply. So CH bond is considered to be negligible. There is no as such electronegatividity is there. So I have already told you that this can be of two types, plus I or minus I, because when an electron donor is there who is donating the electron, so obviously that effect is called plus I effect. If electron withdrawing group is attached to the carbon chain, then it is called minus I effect. So you can check it here. This is a decreasing order of the plus I. So the group which releases or donate the electron cloud is called plus I effect. And this is a series that you can see. Hydrogen, deuterium, tritium, and methyl, ethyl, like this. More the methyl groups are electron donating groups. More the groups are attached, or the compound which have electrons that can donate. So that are, you can simply say, are which they are electron donating groups, and they produces plus I effect. But on the other hand, there is a minus I effect is there. And in this electron withdrawing, it withdraw the electron clouds. So it will say, so more the positive or halogens all are electronegative atoms. So let's take one example from here. So here if you see an electron withdrawing group is there. This chlorine, it can be bromine or the nitro group. So if X is electron withdrawing group, it will attract the electron from this sigma. So electrons, they are going to be displaced. So it generates a delta negative charge on the electronegative atom, but electropositive charge on the other carbon atom. So as it is, increases, displacement is increases, partial charge are getting, you can see here, more partial positive charge is going to be increased. but there is no effect on this because it is just up to the third carbon. And it is a permanent effect, guys. You should understand it is a permanent effect. That electromagnetic effect that we have studied in the previous video, it was not a permanent, that is a temporary effect. Because if the attacking reagent will be there, then you can say yes, it is a uh, electromagnetic effect. If there is no attacking reagent is present, then you will say there is no electromagnetic effect can be positive, either positive or negative. Okay. So here electron donating group like methyl groups, they all are ethyl group, they all are give the electrons. So because they are giving, so it will generate partial positive charge, but all these carbon they will have partial negative charge. Okay, so I hope you both understand. Inductive effect is the displacement of the electrons and the generation of the partial charge on the carbon chain due to the presence of electronegative atom and partial negative charge on the carbon chain due to the presence of electropositive atom or the electron donor. So it can be plus I or minus I. So basically, we are talking that the any two. So whether it can be partial positive or partial negative, means electron releasing group can be attached or electron withdrawing group can be attached. That will shift the electrons towards less selective atom towards more electronegative atoms. So inductive effect, yes, it is a permanent. So what factors that can affect the inductive effect? First is the distance. So it will not work after the third carbon. More the distance, lesser will be the inductive effect. Degree of the carbon. So if you know this is a partial primary carbon because with this carbon only one carbon is attached. If with this carbon two carbon are attached, then it is secondary. If three carbons are attached, they are tertiary. So more electro donating groups are there. That's why more will be the effect. Okay, more inductive effect will be, but it is a plus effect. Which effect will be more? Plus I effect in this case particular. And also with the hybridization case, we can also check whether the inductive effect is more or not. Simple. You have to check the S character here. Here S character is 50%. More the S character, more the you can say more it is close to the nucleus and more you can say simply more S character, more close to the nucleus, more electron activity, it is more polarization of the bond, so more inductive effect will be there. Now, these are some examples that you just understand like OH, CO, NH2, Cl. They all are electron withdrawing groups, but all the alkene chains they are electron releasing groups. So, if in the case of the alkyl chain, more the carbons more will be the inductive. Now, suppose you have this question. This is HF, CH3COH, and here it is CH3CH. H is a donor atom because fluorine is more electronegative, so it will have minus I effect and it is have plus I. But OH, because oxygen has a lone pair of electrons. So, but methyl group show plus I effect. Here, obviously, the chain is alkyl chain, so N is having, electronegative atom rather than the carbon, more electronegative than because of the smaller size. So, we will say it is having minus I. Oh, okay. So, if suppose you have this example that fluorine, chlorine, and bromine is there. So, who is the more electronegative atom? Fluorine. So more electronegativity, more displacement of the electron will takes place means more inductive effect in case of fluorine, then chlorine, then bromine. Okay, here if you will see with this carbon, with this one is the chlorine group is attached and one is the carbon. Here two carbon, there is three carbon is attached, so it is tertiary. So more inductive effect will be with the tertiary one that we have already done. प्रीवियस स्लाइड्स में हमने किया है ना ये वाला. Yes, because more the electronegative group, more the stability of that particular carbon, and more will be the inductive effect. Okay. So, guys, very important point it is that how inductive effect can help to determine the acidity and the basicity of the compound. Suppose you have given two examples, okay, like formic acid is there and acetic acid is there. In formic acid and acetic acid, we have to check who is more acidic in nature. So I'll give it this example to you from here. So this is a formic acid and this is a acetic acid. In formic acid, COH is there. Here it also COH is there. But you have to understand what are acid. Acid are those guys which give protons in the aqueous medium. What is proton means H positive, which give H positive. They are acid which give OH negative. They are bases. Either acid and bases can be defined in many terms, but we will just say here acid. So if suppose this is the case that this H is going to be released breaking after the breakage of this carbon, oxygen and hydrogen. Now, tell me about this group. This H is a electron donating group and this is also electron donating group. This will give the more electrons. This oxygen is will getting stabilized. So the polarization of bond is this oxygen. It will, attracted the electron and easy. It will be easy in case of this. But here it will not easy because methyl group is there. It will make this bond more strong. It will not easily be broken. So if I'll say simply, because when any electron withdrawing group is attached, that is electron donating. But here it is a, if any electron withdrawing is group is attached, it will increase the acidity because it will take up the electrons and that bond is getting weaker and easily proton will go. But in case of electron donating group, that group is getting more closer, more strong than the electron withdrawing group. So in case of electron withdrawing, they increases the acidity, but electron donating group, they decreases the acidity. Simple. Okay. We can also check for the secondary, tertiary, and primary. Here it is primary, 1 chlorine, there are 2 chlorine, and there are 3 chlorine. More electronegative more electronegative atoms are attached, they will attack all the electrons. This can be easily been broken. So according to me, tertiary will be more acidic. Yes. Third one will be more acidic. More polarization of the OH bond will be there. And in case of that hybridization, more acidic character, 50%. Here just 25%. I think here it is 33 something percent. So more S character, simple. More S character on the carbon, more it is more its electronegatividity and hence more acid. Simple. So guys, I will close this session of inductive effect with the difference with the electromagnetic effect. In inductive effect, we work on the sigma bond only, but in the your electromagnetic effect, we will work on the pi bonds. Here displacement of sigma bond and here their transfer of the pi electrons. Okay. But in inductive effect, obviously it is a permanent effect, but electromagnetic effect is a temporary effect. Why? Because if the attacking reagent is there, then only electromagnetic effect can be seen. And it doesn't require any attacking reagent, your inductive effect, but electromagnetic effect required a attacking reagent to for this effect to be arise. Okay, so this is the main difference. So I think in your exams we can have seen these type of questions that what is plus E and minus E effect, plus minus I and plus I effect, what is the effect of inductive effect on the acidity of any compound, how you will compare with the hybridization as character. These type of questions can be asked with this topic. So thank you guys. I hope you have understand this topic very well, and must see that another video so that you can understand the actual concept behind. Thank you so much.